hitting the record button, sharing my screen. I got multi-share turned on. Okay, so today, guys, is actually going to be kind of a light and fluffy lecture. Mainly because we're going to go into something new, and I want to do it in the 2-hour lab section. I don't want to do it here. So what I want you to do today is I want to give you time to work on your projects. I want to make sure that you're setting up the features at the assembly level properly on the elbow and the two cans. So that's really the objective of today. Plus, anything you guys want to talk about is going to be kind of like an open office hours, kind of whatever you want to talk about. So let's see. Start up SolidWorks. That's probably a good idea in a SolidWorks class. And let's see. So today we are down on lesson 17. So again, pretty simple. Excuse me. So go ahead, pull up your can, draw these two items, and then draw this. And some of you guys are probably going to have trouble with the tape to adhere this cut elbow to the can. So we can talk about that if you'd like as well. That's kind of a fun little piece of geometry. In fact, why don't I start with that? So anytime you're going to add a component to your assembly that's actually going to take up physical space, affect alignments, all of that kind of stuff, you really got to have it drawn in. So I'm going to start a new part. Up here. So when you go to make that part,
where are these parts?
Hopefully you already have them drawn. So you had the Coke can as a homework assignment.
Okay.
So go ahead and use your stuff on this one. So to draw the tape that's going to adhere the elbow, I'm going to start off with a simple sketch. And my can is 2.600 inches in diameter. And then, see, we'll do an offset. Of 100 thousandths. So the tape is actually 60 thousandths thick, so I'm going to change that. And let's see, how big is the elbow? So if I want to know how big the elbow is, I'll click on Evaluate and Measure. Click on that face. So the diameter is 1.082. And let's see. I should be drawing this radially, I suppose. Okay. That's not too bad. I think I will go make radial edges on this, because that is actually a little more correct.
Can you go through how you went from those straight edges to the radial edges real quick?
Sure. So I had the straight edges, and then all I did was I drew a line to the center of the can. So I just went from the outer to the center, back out to the outer. And now I'm just going to trim them off.
Okay, gotcha.
So now I've got to constrain this thing again. So I'll try throwing an angular constraint in there. Okay, still underdefined. So as always, I'm going to do what I always do. I'll try dragging stuff to see where it's got a degree of freedom and can change. Okay, so I think I need some construction geometry now. And there may be other ways to do this. This is just kind of what's coming to mind at the moment. And I'm going to make this line and this line collinear. And I'll make Did I get my collinear? I don't think I did. Let's try that again.
The previous one didn't. You didn't do the previous one.
Okay, now I've got a fully defined sketch. And I'm going to extrude this thing. So now I've got a nice curved piece of tape that's going to go nicely on the can.
How high did you extrude it?
I have no idea. I should do it 1 inch because that's the width of the tape. But I'm going to do a trim. So that's why I wasn't real cautious about it. Okay. Now let's put a hole through this thing. So I could be cool and I could put a tangent plane on the outside, but it's just as easy to put a hole on the right plane and punch right through. I'll choose plain simple hole and I will punch 1/4 inch hole. We'll do a through all, get rid of the custom sizing. And there we have a hole through our tape. But I want to be cooler than that. And this is actually a good time to show you guys a cut to the outside. So I'm going to put a sketch on the right plane. I know this is verging on cut extruding of circles, but you can kind of work with me on this one. Let's see, diameter 1 inch. So now if I do an extrude cut and I say, oops, through all, and I flip the side to cut, it's going to cut on the outside of the circle, not cut the inside of the circle. And this is how I drew the tape. And this will mate very nicely to the outside of the can and to your cut elbow. Okay. So this is how I would draw the tape for your elbow assembly.
What should be the material for that?
You're going to go with the manufacturer and the manufacturer part number. So for that, I would go with, let's see, final project, parts list, and let's see, tape double-sided. So the material will be Scotch 3M part number 411. And I would say something like make from, because if you just put Scotch 411 on there, okay, that represents a whole roll of tape. But if you say make from, then it's clear that, you know, you're not going to use the entire roll of tape in the assembly. Yeah, and it's the same thing on the displacer foam. So if you put a material as isocyanurate foam, Lowe's part number 15099, that's a 4x8 sheet. So if you got this little bitty disc and you're saying it's Lowe's 15099, somebody in purchasing may get confused because the call out is for a 4x8 sheet, but you're showing a disc on the blueprint. So you just say make from, and then everybody's clear.
I had a question about the extrude cut of the
Yeah.
circle.
Yes.
How did you get it to keep the profile instead of cutting it?
So that's where this flip side to cut comes in. Okay, if I don't do this, it's just like extruding a circle to make a hole.
Okay.
But when I say flip side to cut, keeps the outside. The other thing I could have also done, let me go in, I'll modify this sketch. I could also do this. And if I cut extrude normally with this kind of arrangement, without the flip side, then you get the same thing. So you can either do 2 circles and use it like a cookie cutter, or you can just do the flip side.
I'm getting an error when I do the hole wizard thing.
Okay, go ahead and take the screen. Points to locate holes are not valid. They may be contained or may be located on edges. Okay, what I would do in an error like that is I would just try making the tape wider.
Oh, okay.
Sometimes in solid modeling, when you have edge on edge contact, it can create error messages. So that's why I always try to have a little bit extra.
All right, I'll try that.
Back in the very early days of CAD, the non-manifold solid error was notorious. We used to fight that all the time when we wanted to put a feature up on an edge.
I have a quick question, if you don't mind.
Yep, that's what this lesson's for.
Is there any chance that the graders hold on to the files that they grade?
Yes,
They do.
Yeah, I hold on to all of the files right till the end of the semester.
Okay. I had a bit of a problem with my computer and it deleted some of my files. So I was hoping I'd be able to get like the Coke can model that I had made.
Yeah,
Okay.
absolutely.
Thank you.
So let me stop sharing. Actually, I'm not sharing at the moment. And I'll go into the homework folder or the homework email, and I'll send that back to you, Jackson.
Thank you again.
Yep, no problem. Okay, do you have your model back?
Yes. Thank you.
Okay. So is there anything else that you guys are having trouble with?
So with these modified Coke cans, we should
Yes.
make our assembly first, bring the parts in, and then modify them. Is that correct?
Yes. So let me show you mine just to be clear. So I have a sub-assembly called bottom cut can. I'll open that up. Okay, this is a sub-assembly. It has the can as a component. And then at the assembly level, I have these two cut extrudes. So one chop the top off and one put that vent hole in the side. And then I bring this sub-assembly into the top level and I assemble it all here. What I do not want to see in your layouts is you guys doing forming operations or making of parts and assembling them at the same part number. Okay. I want you to do all of your part modifications in one file. Then when you're done forming it, machining it, doing all of that, then bring that into the next level up.
Okay.
I have a few questions.
Yeah, Emmanuel.
I share.
Yep. Screen's yours.
Is it? Okay. So let's go back before the split. So I made this can earlier.
Okay, looks
Because
good.
I'm lazy. I'm going to reuse the top part. Instead of drawing the whole thing, I put a split. And I fixed, I designed on top of that. So my question is this model acceptable to you because it has all this great history? And because this part is made out of the can, so I don't have to re-measure everything.
Right, so if you're gonna use the top of that can as a component for something else, maybe that's gonna be your little flywheel or something.
Well, that's the base of the, I can show you. Open. It's the base where the wool, it supports the wool, the, what's that? It's in here.
Okay,
Uh,
so if you want the assembly person to start off with a can and
Yeah.
then cut the top off, then I would do the same thing. I would do another feature at the assembly level. Oh, okay, I see what you're doing. Yep,
that's the wool. Okay, does make sense.
yeah. So what I would do is, I would do just like the cut cans. I would start off with a can, bring it into an assembly, cut the bottom away, and then keep just the top and put that into your model.
So I did it wrong.
Well,
I mean, it's the same thing as here. Because I need two cans. I just again I took the whole can and I
Yeah.
put the split, and I just made the hole, and then I inserted.
so my problem with the way you did it was, let's think about this in a company. So how do you get that can purchased? So you're going to have this, you're going to go and create a drawing of that top,
Yes,
and you're going to put,
of this one, for example, or the bottom one, or this part,
that one, the one you got right now.
this one.
Okay. So what are you going to put on the print? And how are you going to tell people to do the cutting? How are you going to tell them order the can and what can part number to order, and then how to make the modifications? If you
Yeah,
can give me a good story for that, I'm fine with it.
okay. Yeah, I'm thinking to say it's made from the part number. It's gonna be the Coke, the same as the Coke,
Okay.
and cut. Can I put it in gourds? Cut from the top. How can I do that?
So if you said the material is make from part number, Walmart, whatever,
Yeah.
so that they go out and buy the Coke can. And then you're detailing out all the stuff that you want them to actually put in for features.
Okay.
Yeah, I mean, for that one, okay.
Okay. Now, can I stop sharing somehow? And then, and then I have another one.
Yeah, shoot.
Open. No. Cancel. This one. So I made the drawing of this. That's the crankshaft, right?
Yes.
Okay. So I would like to have the total length of this, and I cannot make it flat. For example, I managed to make flat this one. I played a little bit. So I managed to make it flat, open drawing. You see that I have the first sheet is here.
Okay.
I cut it here and then I managed to unfold it. So I can show that this is made out of, this is the length. But I cannot do that with this.
I think under smart dimension, if you put the center line along the whole thing, and then you can say, give me the center line. Let me see if I can do that.
I can take the length for my use, but I cannot put it in a drawing. How can I show it? Can I just put it in gourds made out of that length? I can get.
Yeah, that's the kind of thing I would handle with a note.
Okay, yeah, because from here I can get the length of the sweep.
Yeah, so if you just say, note number 1, make from Blue Demon part number, blah, 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 whatever it is. And then on the second note, say pre-bent length is X inches.
Okay.
Sure.
Yeah.
And I think your dimensions are a little bit off, unless you found a different design.
Oh, the dimensions on.
Yeah. So on the crankshaft, for the Coke can engines I've been making, the displacer goes up and down.
This one?
Yeah, you got that 3/8 is good, but then on the other one that goes over to the balloon piston,
yeah,
that should be 3/16.
Yeah, maybe. I'm not. I'm trying to see exactly how is it. It's experimental. Oh, what happened? Anyway, yeah, maybe you're right. Maybe you say this one should be 3/16.
Yes.
Yeah. Yeah. Maybe you're right. Yeah. Okay.
Okay. I just, if you're going to go through the work to build something that nice, I just want to
Yeah.
do my best to help you make it work.
I don't know. Now I don't know what happened now.
Yeah, you got a concentric that's broken somewhere.
But I was trying to rotate it to see exactly how it works. I still don't really get how it works, so I don't know. But
Okay, so the way this thing works is really, really simple. It's just like imagine you've got a balloon. And you take a balloon, it's filled with air, and you put it inside of a hot car. The thing expands. And then you step out of the hot car. The air inside the balloon contracts. And if you keep doing that, if you go back and forth, inside, outside, you'll get a cycling of expansion and contraction.
Okay, but
Now, if you hook up the side of the balloon to a crankshaft, and you have a displacer that can just slide it back and forth into the car and out of the car, it would function exactly the same. So you have a fixed volume of gas, and you're alternately heating it and cooling it, which
so
is, go ahead.
sorry. So there goes. It doesn't go in circles. It goes back and forth.
Exactly. It goes from the top of the displacer to the bottom of the displacer.
Displacer, you mean the wool where the steel wool is?
Yes,
So the wool moves the air up and down.
exactly. Yes. It displaces it from the hot side to the cold side. And that causes volumetric expansion and contraction as the air shuttles between the hot and the cold.
Okay.
And that volumetric expansion then drives the piston, which pushes the piston up and down. And as long as the two are connected out of phase by 90 degrees,
Yeah.
the system will continue to rotate.
Okay. Oh, I get it.
So is it kind of like the balloon drives the crankshaft, which then drives the piston, which then drives the balloon? Like, are they kind of
Absolutely.
together? Okay.
Yep, that's exactly it.
Have you posted the video yet?
Of assembling the engine?
Yes.
I have not, and I am a delinquent on that. I got to get that for you guys. In fact, we actually have time. If you want, we could do that right now. I'll set up my little desktop camera. I've got all the parts literally sitting next to me. So here, why don't I take my headset off? I'll run over and get my auxiliary camera, and we'll go through that. All right. All right, what do you think of that, guys? Can you see the workbench next to me?
Yeah.
Okay. So what you're gonna do, turn my camera so I can see what you're seeing. Okay, so you're gonna start off with a can. I would recommend putting the vent hole in right here at this level. When you have your can, I pre-made my displacer assembly. So I've got the wire going through, it's glued in place, I've got my 2 discs. And when you drop it in, it should fall just like that. Okay, there should be no binding at all. If you do have any binding, then you're going to need to just take some sandpaper and adjust the diameter on the displacer. Okay. I also pre-made the cut top can. I've got the crankshaft hole right there, and I've got the little bitty hole in the bottom. For the hole in the bottom, I'm going to show you guys how to do sketching on a drawing. So you can actually make a little circle of paper that's the same diameter as this indent in the bottom of the can, put a center mark on it, drop it in place, and that will locate the center of the can. Because it's not hard to imagine if you get this hole off, let's say it's way over here, then if I try to put my displacer rod in, I'm going to be dragging on the side of the other can, and you'll have too much friction for your engine to work. Okay, so we're going to assemble the displacer into the bottom of the can. And I've included a little push pin in your kit, which is just a hair undersize. So what I recommend you doing is push the push pin through the can, then push the displacer rod through. And as you can tell, it's a very, very close fit. And you've got to have a close fit right here to keep the pressure in the container. If your pressure leaks out, then the engine won't run. Okay, right here, I've got my pre-made elbow assembly, and I've got my tape on it. I'm going to take the tape covering off. Come on. And this stuff is sticky as all get out. Okay, there's the sticky surface. So I need to cut a vent hole in here. Accuracy of the hole is not critical. Even as ugly as that is, that's not too bad. Yeah, that's a little bit better. Yeah, I'm going to stick this on the side of the can, and I'm going to align with my vent hole. Notice that I did put the proper curvature right there. You've got to get an airtight seal right around here, whether you're doing it by glue or whether you're doing it by double-sided tape. And here's another important part. Right in here, where the vent hole goes through, make sure to push any flash into the elbow. You want a smooth running surface right in here. So I'm going to take the tip of my pliers and I'm just going to push that hole open. But into the pipe where nothing's moving. So again, we'll do another test. We'll make sure that our displacer drops in easily. Which it does. And at this point, we can assemble our two containers. The first assembly is always hard, folks, because you're actually stretching the metal on the bottom can. So I'm going to put that in position.
How far does the foam goes? Does it go above the hole of the elbow of the vent? The piston. I mean, the piston goes. How high it goes?
So the two foam discs are called the displacer.
Okay.
And yes, they will partially cover the hole at times.
Okay, but it doesn't go above the hole.
I believe it can.
No, I mean, can you see? So the hole will be below the displacer at any point.
Yes, it will. And that's okay. Because as long as you have a running clearance, you're not moving that much air into the piston. So that amount of leakage is just fine.
Okay.
Okay, so at this point, I've got the top can pushed into the bottom can. And I can see a little bulge line right there. I don't know if you can see it in the gloss. It's about an 1/8 inch overlapping. You don't want to push it too far. But you should not need any tape, anything like that. And it will make a very nice airtight seal just from the press fit.
So the eighth of an inch that you're talking about is how far the
The
top one goes
overlap.
in.
Yep, the overlap right here.
Okay, and when we make our drawings, we don't need to account for the bulge. We just need to account for the depth down in.
Correct.
Okay.
So what you might want to do, I wouldn't even really try to account for the overlap. So if you just take and do an overall distance from the bottom to the top, that would be fine, because that's a more realistic way to measure. So if you tell the assembler, okay, put this on the table, press the top one in until you have a height of X, that makes sense. Plus, in another class, we're going to talk about gauges and measuring and all that other stuff, which, you know, we can't get into that in this class. Okay, the crankshaft. So I've got my crankshaft all bent up. This thing, let's see if I can get this one in. I like to go in from this side, so I'm coming in from above the elbow. This is probably the hardest part, at least for me. I come in. Okay, when I get to this next bend right here, this is where it generally gets dicey, and you just got to be real careful and slow. You push the next one in. Now I'm right on the running surface, and I'm good to go. Okay, I have my CD all pre-made. I've got the little hub that I'm going to give you that's made out of PLA. I've got double-sided tape between the hub and the CD itself. Let's see. What I would recommend you do is put one of your nylon spacers right in here. And here is one of the little nylon spacers.
Do we have a drawing for that?
Yes, you do. It's a McMaster part, and I want to say it's really exotic. It's like a 1/4 inch in outer diameter, 1/4 inch long, and 1/8 inch hole.
Okay.
Okay, this is where I need 3 hands. Put that on. Now, do not worry about creating the bend at this point. I mean, there's no real good way to get this thing all assembled without bending at the assembly level. But for you guys, just draw a fully done crankshaft. We're not gonna worry about that. So let's see. Maybe able to bend this with my fingers. So what we're gonna do is our goal is to have this wire inside the little trench in the CD adapter. Maybe I'll get away with it. Okay, so I bent mine over and it's sitting in the trench. And it should spin freely. If it doesn't spin freely, then you got to go back and fix some of your problems. Okay, one of the problems I have is I don't have my crankshaft lined up with my pipe elbow. That's going to be important. So I'm just going to pop this thing out again. First couple times, these are just awful to get in and out. There we go. There. Okay, at this point, we're pretty much there. We're in good shape. At this point, you're going to want to cut off the inner music wire and bend a hook, which we will then connect with the safety wire going up to the crankshaft. Okay, our hook is good to go. And that's really all of the hard part, folks. When you go to do the safety wire, I would encourage you to do a pre-bent connecting rod. Makes life much, much easier. So for example, if I take my soft piece of curly safety wire and I wrap it around the end of the crankshaft, I can pre-form that twist that you drew in so nicely. And as you can see, all you need is just one or two good wraps. And you don't want it to be tight. It should be able to do this. It should be able to rattle back and forth. If it's locking up in position, it's too tight. I'm going to take that off. And I'm going to form my other end as well.
Would you recommend drawing that as just as its own part, or
Absolutely. Yep.
okay, so not as like in a sub-assembly with the crankshaft or anything?
Yeah, you're going to want these connecting rods to be their own parts. I would put these in at the top level. You could make a sub-assembly of the displacer and the displacer wire. That would be absolutely fine because they always move together.
Okay.
Okay. This I'm a little bit underwhelmed with. Your displacer should fall down on its own. So I've got a little bit of hang up in mine. It may mean that the top can is rocked side to side. So I would go find the source of this problem next. And I would also pre-make these wires. So you should have the length from right up here to wherever the end is. And that should have gone on when I put the crankshaft in. That would have been really easy to slide right in. Let's see if I can take this thing out the other side. It'll be a whole lot harder. And it's sliding it into the can is why I told you guys to always make your crankshaft bends at 45s. If you try to do it at 90s, it just doesn't go into the can. It physically will not go together. That was lovely. I got very, very lucky. I have the twisted end on my crankshaft, and I've got the displacer connecting rod in place. And then if I had it all done pre-made, I'd be able to slide it right onto the displacer shaft. Okay, try to keep this displacer rod just as low as you can. That's about as high as I would ever want to make one of mine. So I'm going to have a heck of a time right now trying to get this thing on in the proper length. There we go. I can just trim that off. The other lesson is never twist on a Leatherman. You ruin the pliers part. There. Okay, so again, you've got to get this thing so that it always runs freely. So you may want to apply a small piece of tape on the end of the displacer rod. And you may also want to apply some small pieces of tape to keep this connecting rod from shifting side to side. But that's pretty much it. You're going to put the balloon here, put a rubber band around the balloon. I would put a bolt through the balloon and come up, and then you're going to connect to the crankshaft right here, and you're done. And I will finish this one up off camera because the rest of it is just a lot of fiddling around getting it to work right. Plus, I also have a little setup sheet. So I have a way to get my rods all exactly the right size beforehand.
Where do we put instructions? Should we put notes on the drawings?
If you need to, sure. If you wanted to put something like, torque the nut and bolt to X inch ounces, that would absolutely be something you'd put on the drawing as a note.
Yeah.
Anything that you can't cover with graphics, by all means, put it on as a note. Anything that's like torque or paint notes, if you want to paint something a specific color with a certain brand of paint, absolutely perfect note material.
How do you want us to model the balloon?
Very, very simply. Okay, so the balloon, all I want you to do is something like this. And we're after 9, guys, so if you need to take off, that's fine.
I have one quick question before I head out.
Yep,
Um,
shoot.
When we're doing features for an assembly, so like if we're doing an extrude cut, you go insert, cut, and then
Yep.
choose your sketch.
Yep.
It's doing the thing where it's not showing up. So like I have to restart SolidWorks and then try it again before the feature will show up. But
Okay, that's
on
freaky.
on the feature scope, do you click all components or selected components?
It depends. So if you want to cut through everything in the assembly, that might be appropriate. So for example, if I'm welding up some tubular steel on a trailer frame, yeah, I might want to go through multiple pieces of steel, multiple components.
If you just have one piece though, it shouldn't matter, right?
Nah, it shouldn't.
Because it doesn't show up when I do all components.
Okay, so to the previous question, this is all I want for the balloon. Just revolve an L shape, put a hole in it if you're going to use the bolt, call it good, and you're done. No more difficult than this. And just put a note that says the material is Walmart part number blase blase from the list. Okay, Sam, show me your issue.
Oh, I got it now. It's just when I do it, it doesn't show up until I do it again. I think it's a similar issue like you had in the lecture where with the whole wizard, it wouldn't show up.
Yeah, I don't know
I don't
what
know.
that was all about. That was
Yeah.
just plain weird.
I had the same thing a couple of times, so I'm not sure.
I mean, it could be a video card thing. It could be a bad update thing. I honestly don't know.
Okay.
Anybody else have any other questions before we have to shut this down?
A quick question about the homework. Today is the tractor bucket. I think that's a deadline for today, right?
It was actually yesterday, but yes.
On the syllabus, it's anyway. Okay. You want to make? You have an assembly. You want us to make the drawing and put the notes of the weldment of the welds.
No, I took that off, Emmanuel. All I want's the assembly.
Oh, just the welds.
Yeah, that's all.
Okay, I will send you.
Done.
Okay.
I had a question.
Yeah, Ethan, go ahead.
So for the Coke can, I put 2 of them in my assembly, and then do I just insert cut, and then I just cut one of them in half from there, or do I have to do a sub-assembly kind of thing, or what?
No. Okay, let me show you on mine. Okay, so what you're going to do, here is my bottom cut can. So what I did on this one was I brought the whole can in, which is this. Here's my whole basic can.
Yep.
I brought it into an assembly, and at this assembly level, I did 2 cutting operations. So it's a lot like bringing a raw casting in and doing 2 machining operations on a raw casting.
Okay.
And then I brought that machined part into the top level and assembled it. I did the same thing with the top can.
Okay.
I brought a single can in, I cut it up, and then I brought that cut ready to install piece part into the top level assembly.
Did you just cut the can like completely in half?
Then I cut it in half.
The bottom one, is that just like halved, or is it like a certain dimension of where it's
Yeah,
cut?
you're gonna need a certain dimension because if you pull the displacer up and the displacer smacks into the bottom of the top can, that would be bad. Then your engine will never run.
Yeah.
So you should be able to rotate the crankshaft. I've got this all constrained. See if I can fix that real quick. Oh, anyway, so before you make this connection over here, you should be able to rotate your assembly just like the V8, and you should have the displacer going up and down, and you should be able to check the clearance. Okay. And if you want to look inside, you can do this section view. There. And if I had this all properly set up, I'd be able to rotate the flywheel or the CD, and I could watch this displacer go up and down, and I can see whether it's going to smack on the top of this dome or if it's going to hit on the bottom of the top can.
Mm-hmm.
And that's what you're going to be looking for. And that's what's going to then set the height of where you cut the bottom can. Because the taller I make this bottom can, the more space I have in there for the displacer to move.
Mm-hmm. Okay.
Kind of sort of makes sense.
A little bit. Also, just a quick question. What's the other, the little part inside of the elbow that connects to the can?
This is the bushing.
Okay.
Yeah, that's that hex head bushing. So you push it in, and once you push it in, that's it. Those things get really, really tight.
Mm-hmm.
And then you're going to have the hex head out over here, which then you're going to trim off. Or you can leave it on and you could just sand it to match the diameter of this can. Either way, it doesn't matter to me. The whole point of this little bushing was to just give you more bonding area.
Okay.
I just found that this wall was just too thin for my taste when I put the first one together.
Can you show us how to model the inside of that bushing?
Model the inside of the bushing. Not really sure what the question is. So here's my bushing. And then I brought this into my elbow assembly.
McMaster made it seem a lot more complicated.
McMaster models are terrible. They are just awful.
Could you post the drawing of the one that you did?
Yeah, you want me to post a drawing of this bushing?
Yeah, that'd be great.
Yeah, I can do that.
Thank you.
So then I put the bushing into the elbow, and then I did a hole right here. And I just positioned it off the top of the elbow. So the 0 shows that I'm on the center line, and then I have an offset distance from the opening over here. And that was how I cut it. And I should probably have had the tape in here as well. Okay, so did that answer the question, or did I just confuse you guys more?
Yeah, that did.
Okay.
What is the cosmetic thread on the bushing? I forgot to put that in there.
On mine, it's 1/4 MPT. So you're going to do taper tap, and then you're just going to choose 1/4 inch. And it should put the hole in, it'll put the cosmetic thread in, it'll do all of that jazz for you. Okay, guys, so we're 15 minutes after. At this point, I'm going to sign off unless you guys have any other questions that you're just dying to have answered. But no, I do not have next week's lottery numbers. Going once? Going twice?
There is no homework for next week?
Well, I got to give you some homework. There's nothing for this, though.
Okay. Okay. I messed up the dates. I went with what is the syllabus? And the 16 is due on next week. But
Yeah, somehow the syllabus is off by a little bit, which is,
I remember you said something about the tractor, and I said, okay, is it next week or is it today? And now it's it was yesterday. Anyway, I'm
Yeah.
saying now, whatever. So it's just the welds, nothing else.
that's it. Yeah.
Okay. Okay.
Just get used to applying the welds at the assembly level and call it good.
Okay. Okay. Thank you.
Thanks, Manuel. Okay, guys, I'll catch you later.
Bye.
Bye.